Okay, hey everyone. So this is going to be a bit of a different setup than usual, because as you can see right here, we're not really looking at Ubuntu this time. So that's ChromeOS. Effectively, that's like remote screen sharing on a Chromebox I've got in my basement, but you would get effectively the same thing on any modern Chromebook. For those who've never seen a Chromebook, and you've got Chrome is quite permanently integrated, so it's your main web browser and also the main source of apps. There is native integration with Android, so as you can see, it's trying to motivate me to install the Canadian COVID app right now, which is not very useful on a Chromebook, but I mean I've got it on my phone. But so you could also install Android apps, and they all mix in the launcher here. For example, you can see I've got Telegram and Spotify, both of which are actually Android apps, and then the rest are ChromeOS apps. Now, the thing that's kind of interesting is they've added support for Linux applications. The naming is always kind of funny because, I mean, ChromeOS is technically Linux. It's a bit of a special Linux distribution, but it's effectively a Linux distribution. Yet they've got that feature called Linux apps. So the way you find out is if you go into settings, then there is Linux beta here, which you can see in the menu, and then you can turn it on. When you turn it on, you get this wizard that asks you to, gets you kind of through the thing. You can choose your username for use inside that environment. You can choose how much disk space to give it. I'm just gonna go with the default of 5 gigs, but I could probably go with something larger. I think this box has like almost a terabyte of SSD in it. And then you click install. What it does is it effectively downloads a small virtual machine that's based on some very heavily modified Gen 2 distribution, and that includes just the basics needed for LXD to run. And so it downloads that from Google, then it unpacks that virtual machine, creates an instance for your user, and then starts it. The reason for that is all of the different Chromebooks ship with different kernels from different manufacturers. There is not much consistency at that level. So Google went with the approach of shipping a virtual machine where they are then in full control of the kernel and can give the best configuration for LXD to work. Once that's done, you get dropped into a terminal, and that terminal gets you a normal user account. Can just close those things. A normal user account in what's effectively a Debian container. So we can see it's a Debian 10.4 container that gets created by default. If you're not convinced that this is actually running on LXD, you can check dev.lxd and you'll see there's the dev.lxd socket there, which confirms this is actually running on LXD. It's all nicely hidden away. As far as the user is concerned, if we leave this thing, all they need to do from the launcher is look for terminal, and then they click on terminal, and they immediately get a shell inside that container, inside that virtual machine. And it's completely transparent. If you want new shells, you can just create new tabs. It all spawns in there, all quite nicely. Now, one way you could play with more LXD is by first getting root, and then installing snapd and squashfuse. So it's a normal Debian system, so you can install debs, you can do whatever you want in there. There's nothing particularly special. The one thing to keep in mind is that this is a, well, in this case a Chromebox, but it's really the same as a Chromebook. And some of those have very slow CPU. This is one of those. I think it's some Intel Celeron type CPU. So you'll see sometimes that things are a bit slower than you might hope. That's normal. There are very high-end Chromebooks you can get, like the Pixelbook from Google would be one of those, where you can get very nice and fast i7 with like 16 gigs of RAM and NVMe storage, and those would be super fast. This is not one of those. So now what you can do is snap install. First install core. Actually, I could have did it in the sudo in this case. this will just cause snapd itself to reload from what's in the core snap, which then provides the basics needed to actually install LXD. So if we did that, that's going to be installing LXD inside the LXD container. Would that work? Yeah, I mean, it works fine. It's a bit weird and to some extent maybe stupid to do it that way, but you definitely can. So let's just confirm that we actually can do this. In this case, you do say that things are actually a bit slower than you might see on an Ubuntu system. I believe it's because it's like creating some font caches or something. Yeah, bingo, that's what it's doing. It's updating font config. So it's this line here. That will take a few seconds to complete. Then the snap will be installed. Let me actually full screen that, so it might be easier to read. Not sure if we can easily increase the font on this stuff though. Don't think it's as easy to do as on Linux. Well, on a regular distro with a GNOME terminal or something. Anyway, let's see if it's done. Kinda. Okay, so I did the font config on the core snap, now it's installing the LXD snap. That should go faster, because it doesn't actually need font config or anything. And we're done. Okay, so let's go back to a regular user. Actually, let's get a new shell just to get the refreshed environment. There we go. That seems to hint that by default we did not get added to the LXD group. That's fine, we can fix that. And get yet another shell, and this time it should have all we want. Or not. Fine, we'll just do it the old-fashioned way. Okay, so now that's actually starting that nested LXD. And we should get, yeah, LXD info, and obviously nothing there. Now, as I said, that's probably not what you actually want to do, because it's all running on LXD, so why would you do LXD in LXD? That doesn't really make that much sense. It's also not going to have the best integration with ChromeOS if you do it that way. Instead, what you want to do is start a Chrome terminal. So that's a bit different than what we're dealing with. So it's you do Control-Alt-T and you get into this thing, which is Chrome shell. Then in there, you can do vmc start terminal, which gets you a user shell inside the virtual machine that's running LXD. Now, in this environment, we can go look at what's going on. Oops. Yeah, ouch. Okay, there's some bit of a... I'm just gonna do it again. There's something wrong with this particular window. Okay. All right, so this is working. Now if we go look, this time we see all the processes running, so that's definitely not in the container, we're on the inside the VM. We can see we got a shell through a process called vshd that's managed by ChromeOS. LXD is running in there, and we can see the containers running. The entirety of the VM is effectively read-only, except for a specific path called mnt stateful, which contains the LXD config itself. We're a normal user, we don't have root access in there, so you can't do much. But the one thing you can do is this. So you can add actually, let's just do a list of the containers first. You're gonna see one container, it's called Penguin. That's the one that we get through the terminal app. So the terminal app shows that we're on the Penguin container. That's the only container that a normal ChromeOS user will ever see. That's the only one that it manages. But we can definitely do more than that. So what we're gonna be doing is we're gonna be adding a new device to that Penguin container. We'll call the device LXD. We use a proxy device. We'll have it listen on a socket in the guest, so inside the container. On the host, well, actually in the guest, that's going to be at srv LXD unix.socket. On the host, we want this to connect to mnt stateful LXD unix.socket. And we want the socket in the container to be owned by UID 1000 1000. So that's the normal user account in there. I suspect the issue might be that I did not create a directory, so let's just go ahead and do that. So we want an SRV, oops, SRV LXD directory. I can actually move the other one. Okay, let's try that again. Yeah, there we go. Okay, so now we've got, we don't really need to deal with that VM anymore. That's pretty much all we ever needed there. So we can close it, close that, and go back to inside our container. Now if we look, we've got an SRV LXD Unix.socket file that's owned by us. What that lets us do is add a new LXD remote to the CLI we've got. We'll call it Crostini, and the path is Unix.socket. So this. And I made a typo somewhere. I forgot one slash. There we go. Once that's done, we can switch LXD remote. So right now, if we look at the list we have, the only two container type remote we have are local. So that's what we are using right now. It's the default, which currently runs nothing. Or Crostini, which is the one we just added. So what we're going to be doing is we're going to be switching the remote over to Crostini. And now if we do LXD list, we see ourselves. So we see Penguin. We can see some of the specialty that's going on there. As I said, we've got one container, it's called Penguin. If we look at its config, it doesn't have a ton of weird stuff, but it's got some. So there's a bit of special UID and GID type mapping that's going on with those containers. It's also exposing a container token at dev.container token. That's probably just for authentication on some stuff, some integration with the host. It also exposes a SSH key that's used for ChromeOS itself to connect into the container and access things like the home directory to then integrate with ChromeOS itself. And there's actually far more that's now hidden inside the default template, default profile that's being used. That exposes a whole bunch of other stuff. So it gives us a network interface, it gives us access to Fused and to a bunch of other devices, including USB device pass-through. Some of the things that are most interesting, external devices can be accessed. So if you plug like a USB stick, you can make that accessible inside of this environment. And the same is true of some amount of shared files on directly from ChromeOS into the containers. Not everything is exposed. You can actually, there's pretty fine-grained access control you can do to just expose what you want. But that's how it's visible inside the container. There's a question around GPU pass-through, and technically yes. So they do use some amount of GPU pass-through. If we go look at the default profile and we look at the list, you can actually see at the beginning DFDRI card 0 and DFDRI render 0, or render D120 actually. Those two are effectively the host GPU being passed into the VM and into the container. That's being done with Virtual GPU and Virtual GL. So it's effectively a virtualized GPU. I'm not even sure it's going to show up at all. We don't actually have PCR utils. Let's install that. Right, so when seeing the sound pass through, because you can actually access the sound card. Oh yeah, and there is a Virtual GPU showing them there. So yes, you can technically do GPU accelerated applications from within the container. That's specifically configured for the default Penguin container. We'll see some of that a bit later. Now that you actually have access to the host, there's some, well, to that VM host and the parent LXD, there's some stuff that's kind of interesting. One is that IPv4 and IPv6 addresses, they are not your normal private subnets from LXD. This technically is a private subnet, but it is routed such that Android apps and ChromeOS itself outside of the container can access those addresses. And your IPv6 address, if you do have IPv6 connectivity, it actually pulls an address from your parent's network directly. So in this case, this is a fully public address that's been added. Now that we've done that, we can use it as a normal LXD. So you can totally do Ubuntu 20.04, say the cloud image, and container called U1. And that's instructing the LXD that Google ships in that environment to create a new container for us using a normal image. We can do the same with, say, CentOS 8, call that C1. Or we can even do, I don't know, Arch Linux. So any normal LXD container image works perfectly fine. And you can just create your instances and they'll show up in there. So there we go. They're all running. Alpine is still Arch Linux is still booting, but it works fine. And we can get a shell in there, and it's perfectly normal container at that point. It actually lets you do some interesting things. So one thing you could do is, say, install a web server. So we're just going to be installing Apache 2 in this case. Well, this is going to be a problem. I'm afraid I'm going to have to be right back. I need to actually go click on that on the physical machine, or else I'm going to get kicked out, which is special. I'll be back. Well, this is frustrating. Anyway, first time I get this behavior, but yeah, it looks like the screen sharing thing asks the system to confirm every so often that it's still fine being screen shared, which you can't say yes to remotely. So that means I need to run down to my basement every whatever time this thing shows up. That's gonna be interesting. So we've got Apache installed now. And so let's start the web browser, go look at what the address is again. So that you want container, the address is this, the 205 address. And there we go. We're running against Apache, running inside that container. I would actually expect you could do a few more things, like and launch a completely normal full CLUD image for Ubuntu. Oh, whoops. Okay, well, that's gonna be a problem. So that's a reason to maybe allocate more storage than I did. Okay, fine. Let's clean up stuff a bit. Let's delete some images for good measure. Deleting all the images and then launch the image. That should have cleared some space. I should be fine now. While that's going on, we can take a look at that file sharing bit. So as I said, inside the Penguin container, you can look at MNT and you're gonna see something called ChromeOS. And then in this case, you see my files and then a foo directory. The way that looks like in the File Explorer in ChromeOS is like that. So we see that foo directory, and if we go in there, it shows this folder is shared with Linux. Now, if you want to make another one, I can create a new directory, call it blah. If I look in there, blah does not exist. Then if I go right click on blah and do share with Linux, now it does. So it's a very nice and convenient way to expose just what you want. And the other side of things is you can access Linux files directly. It's listed here as Linux files, and that shows you effectively your home directory. So if I was to touch foo, I see foo. So your home directory is directly exported. And the same is true with to some extent with what's available on the Android side, where you can access the pictures, movies, and music directories from the Android container that they also run. So that integration is really quite neat. Now, that container has launched, so what I was gonna try and do in there is actually snap install Nextcloud as something a bit more complex than just a plain Apache web server. While that's going on, the other thing we can see is, going back to our Penguin container, we can install graphical application. So it's a frozen bubble. That also happens to be a game with sound, so it's kind of like the worst case scenario for everything. But that's gonna show us some more of the nice integration that you get on Chromebooks. Okay, so Nextcloud has been installed on U2. What's the IP address of U2? Start. I hope that it just runs on port 80. Not sure that it does. We'll see. Maybe not. Well, let's see what port it listens on. Oh, HTTPS. Okay. So it's got like a self-signed certificate or something. Or not. Okay, what's it doing? I don't like SS. When you grow up with a tool, it's really hard to switch to some other tool. In this case, I grew up with NetStart. Okay, so what's it listening on? It's listening on port 80, so it should have worked. And did I just pick the wrong address? 197. I did not. Did you just take long to... Whoops. There. Okay, well, that's clear. Not gonna work. Okay, it just took a while to start. That's why. The address and everything was actually perfectly correct. It just took a little while to start up. And we're gonna get this to finish setup, and then we should get into Nextcloud. While that's going on, let's take a look back at our frozen bubble. So it finished installing. Now let's go onto the ChromeOS launcher and look for it. There we go. So that got automatically exposed onto the Chromebook. And I mean, the game is working. And if it wasn't running in my basement, I would actually get sound too. Just finish that first level. There we go. So yeah, graphical applications just seamlessly integrate in the launcher. That's very convenient because you can install a whole lot of different things that ChromeOS doesn't do. Like one thing would be, for example, GNU cache. That's just one thing that comes to mind for me. Like there's no, I mean, I'm sure there are decent web-based accounting software at this point. I'm running out of disk space again. Seems to be a bit of a pattern with my 5 gigs. Yeah, everything's running out of disk space. Okay, let's delete that U1 container and its associated image. That should clear enough space. So I guess the the conclusion on that front is make sure to allocate more than 5 gigs. Running out of the initial 5 gigs very quickly. YouTube, come on. Yeah, that's the one. Let's just get rid of that image. That should clear the space I need for GNU cache. There we go. Hopefully it's got enough space now. Hopefully it feels like installing. Oh, there we go. While that's going on, the last thing I kind of wanted to show around what you can do with Chromebooks is the rest of the settings that show up in here. So once you've installed the Linux integration, you can go back and click on there, and you can see what folders have been shared and easily remove them other than through the File Explorer. You can see USB devices that are being passed through. It's currently pretty much just supported for phones, so that you can run like an Android development set of tools inside the Linux environment and then use that to push stuff to your phone. You can backup or restore the entire thing, so that lets you download pretty much all of that persistent chunk of data, and then you can restore it either on the same Chromebook or some other Chromebooks. You can also, in this case it's not allowed because I've got it integrated with my domain, I don't allow it, but on a personal Chromebook you could allow accessing the Android environment from within the Linux environment, so that you can push your debug builds directly to the virtual Android environment and just test that way without even using a physical device. You can also do port forwarding. So if you want to expose something you're running within the Penguin container onto your home network at home, you can totally do it that way. You just add ports there and they just become available. So you could do 80 TCP, enable HTTP. Actually, bad example, they don't allow low ports apparently. So you can do 8080 TCP. And then this hitting the Chromebook on its address on the local network would then go onto that container. You can see, and you can get the address from there in the settings. Disk size, you can technically grow it if you want. That requires obviously shutting down the VM and all the containers and then bringing it back up. And you can even share the microphone. If you do it, you also need to restart the VM, I believe. Yeah, it says you need to shut it down. And that's pretty much all it does at this point. But yes, there's integration directly in the shell. Games and whatnot can run accelerated. Obviously, Chromebooks are not known for having the most powerful GPUs, so even that acceleration is going to be somewhat limited. You can run multiple containers. You can access, as we saw, the host LXD pretty easily with just effectively one command you need to run directly in the virtual machine. And the rest is, pretty much normal LXD. Like we can see, they manage a bridge. There's that one default profile we saw that's being managed. The storage pool is going to be ButterFS, so they actually have copy on write working properly as well. The one thing that might feel odd is that it is a bit ancient. So in this case, we installed the client with the snap, so we're getting a 4.8 client, but the server that ships in that VM is LXD 317. So that might also answer another question maybe, which is whether it can run LXD virtual machines. And no, it can't, because it actually, LXD 317 predates VM support. Should Google update to LXD 4.0 or higher, then that would become possible, so long as they also include QEMU and all the other bits they need inside the virtual machine, and so long as the platform it runs on supports nested virtualization. But if it does, then yeah, you would be able to run both containers and VMs through LXD on Chromebooks using the tooling that Google directly ships. Maybe one last thing, and I'm kind of giving up on this thing actually installing by the end of this. Chromebooks. So this has been around for a while. It works on both x86 and ARM Chromebooks. Any Chromebook that's being sold right now supports this. Much older Chromebooks might not. And the other part that might be important is managed Chromebooks, especially those like in enterprise environments or in school environments, might have the feature disabled entirely. As we can see in the settings, this is still very much labeled as beta, and there's more work that Google is doing around integrating this feature for use in enterprise environments and in educational environments. And until then a bunch of those environments will just be completely disabled. Oh, well, GNU Cache installed just on time, so let's see if it works. Maybe another kind of tidbit on that is that's interesting is that ChromeOS itself effectively runs on Wayland. They do expose effectively an X Wayland Oops, why is the actual thing? There. They do expose an X-Wayland layer so that X applications still behave. But you'll see a few weird things, like obviously because they're not, like, ChromeOS is not GTK based, it's not GNOME. The theming can be very weird and not like fully in sync. You might need to do some tweaks here and there. But overall, it does work and does let you run a whole bunch of things you couldn't run normally. People have definitely been running things like Steam in there, and then you can run a number of games that way. That's definitely functional. It might not be the best environment for it because Chromebooks, like a lot of them, are definitely resource constrained, but it's possible. And for anyone who wants to play with LXD, it's nice to know that you effectively have it on just about every Chromebook, and it's pretty easy to get access to it and do a lot of extra stuff with it. Let's take a tiny one. This one we definitely have enough space for. So yeah, all of the normal LXD images just work. There's a lot you can do with this, and that's it I want to do. I want to just check the amount of free space I've got left. So yeah, out of the 5 gigs, I still have 2.2 gigs available. So I guess those 2 containers I created earlier were really using a lot of storage. I guess as a quick thing, we could try resizing that. So, oh yeah, I've got a ton of space, looks like. Okay, so let's do 200 gigs. That way I know this is not gonna be a problem anymore. Resize. Well, surely didn't do this live. Holy crap. Okay, well that's nice. So apparently you can totally resize the volume passed to the VM for storage, for LXD storage. I would be surprised if it would let you do that, let you shrink that easily, maybe? Okay, it says disk size 105. Okay, so it does let you shrink it too, to some extent at least. Can I shrink it all the way back down to 5 gigs? Wow, that's impressive. I did not expect this to work quite that seamlessly. I mean, I know that ButterFS supports both live growth and shrinking. It's just I did not expect Google to actually make use of that. That's very neat. All right, well, that's it for LXD running on Chromebooks. Hopefully learned something. It's really quite neat that we've got LXD out there on hundreds of thousands, if not millions of machines. Well, multiple millions of machines, and we're seeing more and more people take advantage of that and playing with it, because there's only so much you can do with just a web browser and some Android apps. So that really complements everything quite nicely, having the ability to run normal Linux applications from a normal Linux distro, as well as mixing Android applications and a full Chrome web browser on hardware that's nicely accelerated and everything. It's really quite interesting. And well, that's it for this stream. I hope you learned something. Hope that this was interesting, and we'll hopefully have something else for you next week. Bye.